Right, first thing to do is put yourself a little bit of water in your beaker, about half fill it, so deep enough to get the ring in. So I've gone for about that much, so I can dunk the ring completely underwater when it's hanging on the thread. Turn the scales on. Weigh the ring. This is a 9 carat gold, so I know the purity of this. I'm using this as a test standard. So it's 1.52 grams. So we know the ring weighs 1.52. That's its mass. Okay, so next, put the water on and zero the balance. Okay, then put the thread through the ring. You're going to use that to suspend it, allow you to drop it in and out of the water. So actually, once you've threaded it through, you will see here it's dangling on the thread. And what we do is we lower it into the water, watch the balance. You see it makes a reading, and we get 0.12 grams. Okay, so the weight in the water is 0.12 grams. Okay, so just move that out the way. Calculator over. Okay. Oh, what's going on? Hang on, I've got some problems here. Right, calculator. Okay, on the calculator we're going to do 1.52 divided by 0.12. That gives us a reading of 12.6. 1.52 divided by 0.12. 12.6. So 12.67. That's grams per cubic centimetre. So that's its specific density. Okay? And we'll note that down. Okay, so that's our test piece. So we're now going to repeat this process again for the ring that I found recently. So I'm going to zero that, put the ring on, and we get 7.15 grams. It's mass. 7.15 grams. Okay, put the water on, tear it out to zero the balance. Then we're going to put the thread through this ring. As you can see, that's now suspended, and then we'll drop this in here. And that gives us 0.90. Make sure it's fully submerged. Make sure it's hanging freely in the water, not touching the bottom, sides or anywhere. And the water's covering it, so that's 0.90. Okay, so move this out of the way. Clear that, and we do 7.15 divided by 0.90 equals 7.94 grams per cubic centimetre. Now you might be asking, why is he doing this and what does that figure actually tell him? Well, certain metals have a specific density in water and they're all different. So if you don't know what the metal is, if you do this method, you can then go to the tables and determine whether it's gold, stainless, tungsten, silver, and see what it is. So bear with me and I'll just get the tables. Okay, so you can see that 1.52 divided by 0.12 is 12.67, and that's grams per cubic centimetre. Now 9 carat gold has a specific density of 12.7 grams per cubic centimetre. So 12.67 rounded up is 12.7 bang on, which is 9 carat gold, which I know that ring is because that's what it's stamped as and supposed to be. So the stamp that's on that ring is correct. So looking down at the next one, we had 7.15 grams for the weight of the ring, and the water it moved was 0.9 of a gram, which worked out as 7.94 grams per cubic centimetre, or centimetre cubed. Now, stainless steel has a specific density of 7.48 to 7.95. So at 7.94, that ring is bang in the range for stainless steel. So that one I found, which we didn't know what it was, and there's no hallmarks and things inside, is definitely stainless steel. So that's bang on. So you can see how useful this method is. And I mean to say, these pocket scales that I brought, they're model MZ100, which you can see on there. They were only $4.99 UK pounds, so 5 UK pounds, which is about $7.50 I think from eBay. I do a range of stuff on there. This is the 0 to 100 grams. But you must have it at 2 decimal places, and by 2 decimal places I mean, if you look here, it's 0 point and then it's got 0, 0. The 2 noughts after the decimal place, so 0 point and then you've got 2 noughts, that means it's 2 decimal places. So there's 2 figures after the decimal point going towards the right there. So you must have 0.00 to actually do this test. If you get 0.0, it won't work. It's got to be 0.00. Okay.